Section 4 is all about piecewise functions. So in order to work with a piecewise function, we have to know what it is. And a piecewise function is defined as a function that is defined on a sequence of intervals. And the most common example of a piecewise function is the absolute value function. So we know the absolute value function as f of x equals the absolute value of x. But we can also write it another way as a piecewise function. So I can also write it as f of x equals, and I can define it using two different linear functions. So my first one is for positive values of x. So for positive values of x, the absolute value function follows the line x. So that's for x greater than or equal to 0. And for negative values of x, it follows the equation negative x. So if I were to graph this piecewise function, I would still get the absolute value function. So both of them represent the exact same graph, but one is what we recognize as our parent function, the other one is a piecewise function. So we're going to go ahead and work on some examples with piecewise functions. The first one is evaluating a piecewise function. So we're given the function f of x equals x squared plus 2 for x less than 2 and x plus 5 for x greater than or equal to 2. And when you're evaluating a piecewise function, you only evaluate for one of the functions, and it's whichever function your x value falls in for the inequality. So our first value we want to find is f of 2. So both of our inequalities have 2, but we only evaluate it for the one that includes 2. So for x greater than or equal to 2, we're allowed, that one includes 2, and so I'm going to plug it in for my function x plus 5. So f of 2 is going to equal 2 plus 5. So f of 2 is 7. Now you want to evaluate for f of 6. Well, 6 falls in the same inequality at x greater than or equal to 2. So we're going to evaluate again for x plus 5. So f of 6 equals 6 plus 5. So f of 6 is 11. And lastly, we want to evaluate f of negative 1. Well, that falls in the inequality x less than 2. So we're going to evaluate it in our function x squared plus 2. So f of negative 1 is going to equal negative 1 squared plus 2. And negative 1 squared is 1. So f of negative 1 is 3. So when you evaluate a piecewise function, it all depends on which inequality your x value falls in. Now we're going to go ahead and graph piecewise functions. So when you graph a piecewise function, you graph both functions given on the same graph, but you're not necessarily graphing the entire function. You only graph it for when it satisfies the given inequality. So our first example is f of x equals x squared plus 2 for x less than or equal to negative 3, and f of x equals x plus 5 for x greater than negative 3. So you always plug in that number in your inequality into both functions to start off your graph. So I'm going to plug in negative 3 squared plus 2. Negative 3 squared is 9, so 9 plus 2, and we get 11. So I need the point negative 3, 11. So I'm going to change my y-axis to go up by 2's and leave my x-axis to go up by 1's. So at negative 3, 11, I'm going to have a point. And because this function has the equal to, I'm going to have a closed circle. I'm a filled in circle there because that is on the graph. Okay. And now I want to finish what the graph looks like for all my values less than. So for negative 4, negative 5, and so on. So to get an idea, it's going to be a quadratic. So to get an idea, if I plug in negative 4 squared is 16 plus 2 is 18. So I know I have a point at negative 4, 18. So right about here. So if I were to draw my graph, it continue going up for larger values of x. Well, smaller values of x. Okay. Now we need to graph x plus 5. And it follows that function for values greater than negative 3. But I still need to plot the point at negative 3. So I'm going to do negative 3 plus 5, which is 2. And instead of putting a closed circle, I'm actually going to put an open circle there because I'm not equal to at that point. So that point is not actually included. So negative 3, 2, we're going to have an open circle. And then it just follows a linear equation with a slope of 1 for all values of x. So this is what my piecewise function looks like when graphed. For our last example, we can have 3 different functions for a piecewise function. So we have f of x equals 3x plus 5 for x less than 0, f of x is 2 for x equal to 0, and x squared minus 7, and that should say for x greater than 0, so go ahead and change that. Because I already have one for x equal to 0, I can't also have one for x greater than or equal to 0, so I'm going to change that to x greater than 0 only. So we're going to have 3 different graphs on our axis here. So let's start with a 3x plus 5. So I'm going to plug in 0. So 3 times 0 plus 5. That's a bad 5. 3 times 0 is 0. 0 plus 5 is 5. So because we're strictly less than 0, I'm going to have an open circle at the point 0, 5. And I'm going to go up by 1s this time. Open circle. And then because I'm dealing with only negative values here, I want to follow what the graph of 3x plus 5 would be for only negative values of x. So I'm going to go down 3, left 1. It's going to roughly look like that. Next, I want to graph the function f of x is 2 for x equal to 0. And since f of x equals 2 would be a horizontal line going through 2, I'm going to put a point at 0, 2, because it's only defined at that one point. And because we're talking about equal to 0, it's going to be a closed circle. So you can have a point in a graph for a piecewise function. And lastly, we want to graph our quadratic function x squared minus 7 for positive values of x. So for x greater than 0. So we're going to plug in 0 for x. So 0 squared minus 7. 0 squared is 0. 0 minus 7 is negative 7. So I'm going to put a point 0, negative 7, and it's going to have an open circle since it is not included. And then I need to have my graph look like a quadratic, and I could plug in 1 and 2 and 3 to get more an exact picture, but I know it's going to resemble a quadratic, so just going to estimate what that would look like. So this is what our piecewise function looks like graphed. So it's very important for piecewise functions that you graph each graph for their inequality and make sure to pay attention to whether or not it has equal to or not, so you know to have an open or closed circle at